For number 3, we're given the problem, as Evan is driving her car, she notices after 1 hour her gas tank has 7.25 gallons left, and after 4 hours she has 3.5 gallons left. Part A is asking us to represent this information in the form HG as a pair, as two coordinate pairs, where H is the number of hours driven and G is the gallons of gas left. So this is pretty straightforward, especially since we have this, since I kind of wrote it out with our information together. Sometimes it's easier for us to see, to make the pairs, if we do an XY table first. So if we have H for hours and G for gallons, 1 hour goes with 7.25 gallons, and 4 hours goes with 3.5 gallons, and it's gallons left. And then we can make points out of this. Our points would be 1, 7.25, and 4, 3.5. And Part A leads into Part B really nicely. It says find the slope. And remember, slope and rate of change, that's all the same. So I'm going to add a page here, and then we can find the slope. So for Part B, it asks us to find the slope. I went ahead and rewrote my points, and I labeled them x1, y1, and x2, y2. So we're going to do y2 minus y1, so 3.5 minus 7.25, over x2, which is 4, minus x1, which is 3. And you can just put that in your calculator. Remember, let's talk about units as we go here. So on top here, our 3.5 and 7.25, those are gallons. And, oh, I'm sorry, that should not be a 3 on the bottom there. That should be a 1. I got ahead of myself. So we should have a 1 and then 4 minus 1. And in the bottom there, 4 minus 1, those are hours. So that's good to write in as we go, because we do want to, since we're doing a application problem, we do want to include units. So 3.5 minus 7.25 gives us negative 3.75, and that's gallons. And 4 minus 1 gives us 3 hours. And if you put that in your calculator, you get negative 1.25, and it's gallons per hour. That's our slope with the correct units included. Now we have 2 more parts. We want to find an equation, and then we want to find out when she would run out of gas. And remember, the slope is negative because we're trying to figure, or we're working with using gas. So we're going to start with a full tank, and then as we drive, we're going to lose gas. So that's why our rate is negative. So for Part C, we're going to write an equation. I'm going to go ahead and add a slide here. The information I'm going to copy down that we need a point and the slope in order to find the equation of the line. Okay, so now we're going to find an equation of a line. And since we have 2 points and slope, we can use point slope. You can just pick whichever point you want to work with. I'm going to go ahead and work with 1, 7.25. So we're going to plug into our equation. Our equation is y minus y1 equals m times x minus x1. So we're just going to plug in. And again, this first piece of information we plug in is our y1, and that's 7.25. The second piece of information I'm going to plug in is my slope, m, negative 1.25. And x1 comes from our point as well, 1. Now we want to go ahead and solve for y, so we have 2 steps we need to do. Our first step is to distribute our negative 1.25. So the left side of our equation is going to stay the same. The right side of our equation, negative 1.25 times x is negative 1.25x. Negative 1.25 times negative 1 is positive 1.25. And then our last step, solving for y, our last step is to add over the 7.25. So we're going to add that to both sides. On the right side, or on the left side, sorry, we have y left. And negative 1.25x plus 1.25 plus 7.25 is 8.5. This equation is in y equals mx plus b form. This tells us a couple things. Remember, our slope is our rate. So that's how much gas we're losing per hour. That's our rate. And 8.5 actually is our initial value or starting amount. So we must have started with 8.5 gallons of gas in our car. For part D, we're going to use this equation. And something we should probably do before we move on. Remember, X was hours, so that's hours, and Y was gallons. So we can really replace X with H and Y with G. For the last part, for part D, it says, according to this equation, after how many hours would Evan run out of gas? So then our gallons of gas would be 0. So instead of setting this equation equal to Y or G, we're going to replace that with 0 and see what, and then solve for H. So here's our equation, and again, we want to know when we're going to run out of gas, which means we're going to have 0 gallons. So let's go ahead and set our equation equal to 0. And we're going to solve for H. So we're going to get H all by itself. The first thing we're going to do is subtract 8.5 from both sides. So that cancels on the right side of our equation. 0 minus 8.5 is negative 8.5. And then we have negative 1.25 times H, and we undo that using division. When we put negative 8.5 divided by negative 1.25 in our calculator, we get 6.8, and our units here are hours. So she can drive 6.8 hours before she runs out of gas, but then she'd be out of gas, so she would probably want to stop for gas. Definitely, it's 6 hours or so. All right, that's number 3.